in Wildlife on 2.
A sea snake, not only one of the most poisonous animals on Earth, but also one of the most abundant of all reptiles. Not, you would think, very good news for us human beings, but surprisingly, this beautiful animal might well be of help to us, and more surprisingly still, it hardly ever uses its lethal bite against us. But how is it, you might ask, that snakes have come to be in the sea at all? Well, they have obviously evolved from land snakes, and you can find evidence of that on islands just off the coast of Borneo in Southeast Asia, if, at certain times of the year, you search among the rocks. This is a mating pair of banded sea krites. The smaller one is the male. They have not yet broken their link with the land, for they have to come ashore to lay their eggs. Like their land-living relatives, they still retain overlapping scales on their belly, which enable them to get about on land very well. So they represent an early stage in the evolutionary move of the sea snakes from the land to the sea. And what a challenge that must have been. The adaptations needed to change from life on land to life in the sea are drastic. But the sea snakes eventually managed to develop solutions to all the problems. Mating and egg-laying finished, the banded sea krites return to the sea. And here they hunt. On land, snakes are able to taste the air with their flickering tongues. In the sea, that same sense is also used, and they can detect the taste of their prey while it's still quite a long way away in the water. And this is their favorite food, an eel. They inject their venom through hollow fangs just as land snakes do. But there is one major difference. The sea snake's venom is even more virulent. In fact, it's one of the deadliest substances known. Once bitten, the eel has no chance. This sea snake belongs to a different family, and one that never comes onto land, even to breed. It gives birth to live young and is totally committed to life in the sea. It swims with the same wriggling motion as its ancestors used on land, but to make it effective in water, its body has changed shape. Its tail is flattened like an oar, and there's a kind of keel along its length which helps it to drive through the water in a purposeful way. And the overlapping belly scales, which are no longer needed and might interfere with its streamlining, have been greatly reduced. Breathing obviously required major adjustments, for sea snakes, like all reptiles, breathe air. But they've solved that problem so successfully that they can remain submerged for over 3 hours. A third of their oxygen is absorbed through the skin from the water. But they also breathe air directly. Their nostrils have special valves that shut when the snake dives. The surface air is then stored in one vast lung which stretches almost to the tip of the tail. The salt in seawater is also absorbed into the bodies of any reptiles in the sea. The Galapagos marine iguana gets rid of it through a special gland in its nose. It sneezes it out. The only other marine reptiles beside the iguanas and the sea snakes are the turtles. They too have a similar gland beneath the eyelid and cry very salty tears. So the sea snakes also have had to evolve salt glands. Theirs is beneath the tongue. So, after millions of years of evolution, sea snakes have become effective and successful inhabitants of the sea. Swimming efficiently, breathing without difficulty, and free of salt, they can explore the coral reef with ease. A Murray eel, too big to be eaten. They prefer smaller fish, and they trap them in crevices. This reef in the Philippines at the moment is not very productive, for it's been wrecked by a typhoon, which has reduced the coral to rubble. But surprisingly, there are lots of snakes here. This is a traditional breeding area, and despite the smashed reef, they have nonetheless assembled in thousands to court and mate. Hunting through coral reefs, normally rich with fish, and armed with a lethal bite, you might think that sea snakes had no problems at all. But there is one danger that evolution has not had time to prepare them for. Surely their deadly venom will provide protection against even this predator. But no, Philippine fishermen know how to handle sea snakes. And not just one at a time. The extraordinary thing is that the snakes are so passive, and that despite their deadly bite, they rarely try to defend themselves. But then they are in the hands of an expert. Around just one island in the Philippines in 1971, 200,000 snakes were taken. 10 years later, only 1,000 or so could be found there. Taking breeding groups is obviously a bad policy, and it will be many years before that colony recovers, even if it's allowed to. So, sea snakes are big business. The fishermen themselves only receive a small payment for each snake, but there's a huge markup and lots of middlemen. And in the exclusive fashion shops of the world, sea snake products cost a fortune. It's estimated that in the Philippines alone, 100,000 sea snakes have been taken in a single month. Harvesting natural resources can make sense as long as they're allowed to renew themselves, but it's very doubtful if sea snakes can withstand this kind of plunder for long. From their original home around Borneo, if that's where it was, sea snakes have spread through the Philippines and out into the Pacific. The Great Barrier Reef off the northeast coast of Australia has become a paradise for them. Here they have diversified enormously. 30 out of the world's 50 or so species live here. The olive sea snake is a species well known to local divers. The famous underwater swimmers Ron and Val Taylor describe this species as being like a kitten when gently held behind the neck. This is the biggest of all, called Astrotia, which can reach the thickness of a man's forearm and is strong enough to bite through a quarter-inch wetsuit. But again, they seldom use all this power and poison against man. Only under great provocation will they attack. They only seem to kill for food. But even so, their venom, 10 times as powerful as a cobra's, seems excessively poisonous for such small prey as a reef fish. A few fish, however, can apparently develop some resistance to it, so perhaps the snake has had to increase its toxicity to overcome that resistance. But some fish eat snakes. Only a few species of shark attack snakes. For most of the time, these two major predators steer well clear of one another. Some species of sea snake have become very specialized feeders. This one has a tiny head, a long, thin neck, and minute fangs which deliver no venom. It searches the sand for buried fish eggs. But the star success of the sea snake world is this one. It's called Pelamis, the yellow-bellied sea snake, and it's the world's most abundant reptile. A twisting, seething mass of one of its relatives was once seen floating in the sea in a belt 9 feet wide and nearly 70 miles long. It's become so specialized and so successful that it spread out from Southeast Asia into the Pacific and expanded its range across it for 9,000 miles to the east. Just how it's achieved this makes a remarkable story. Here and there on the surface of the ocean, the wind and the prevailing currents cast up long lines of floating debris that are called drift lines. There are floating logs, masses of dead weed, rubbish, and detritus of all sorts. But among it all, there's food. Seabirds regularly fly up and down it, looking for what can be found from the air. And below water, the drift line supplies food for Pelamis. There are all sorts of living creatures dwelling among it. Crabs clinging to a coconut, and barnacles hitchhiking on a mangrove shoot that may have been drifting for months. And here is Pelamis. Like everything else, it has become a drifter, floating almost passively among its potential prey. It usually has a yellow belly, but individuals vary, and the older ones are often darker. Its highly variable tail markings may act as a lure to attract prey, and its generally bright black and yellow coloring may serve to warn off predators. It hunts by stealth. It doesn't see very well, but can probably detect movement close up. The tongue helps it to smell out its unsuspecting prey as it wanders into range. Its deadly venom takes a few minutes to act, and the fish is always moved to a head-on position before being swallowed so that its spines don't stick in the snake's throat. This one has missed its strike and has to readjust its jaws. Though hunting seems to be rather random, it obviously works well enough. The success of Pilamis as a species proves that. But they haven't had it all their own way. In the hide-and-seek world of the driftline, some fish are well camouflaged and go unnoticed. They may also feign death to avoid detection. Pilamis itself, however, as it drifts, is treated by other smaller creatures much as they treat a log or anything else. Barnacles settle on the tip of its tail and sit there feeding on plankton. To remove them, or any other surface nuisance, Pilamis does an amazing trick. It's called coiling, and it's a way of rubbing surface against surface, which, when you come to think of it, is not too easy if you're a floating animal far from land. Those sea snakes, like the banded krites that still come ashore to breed, shed their skins every 4 or 5 months. But Pilamis does it as often as every 2 weeks. It's probably an important anti-fouling adaptation, needed in an entirely oceanic existence. So it seems that Pilamis has developed a lifestyle excellently suited to the surface of the Pacific. But does it stay only there? The answer is no. The next question is, why do snakes dive down so often, when one might think that there was little or no food to be found deep down? And where exactly do they go? Scientists from the Smithsonian Research Institute in Panama are trying to find out the answers. Working from a rubber boat in the drift lines, they catch plenty of snakes and keep them in tanks in their laboratory on board. By attaching a small transmitter, they hope to track the snake and find out what it is doing and where.
Looks like he's gonna die.
A hydrophone picks up the signals from the transmitter as the snake takes it down. How do its lungs and heart cope with the pressure of such deep dives? We still don't know, but it could be that further research will reveal answers and that they will help us understand our own bodies better, particularly in connection with diving. The record depth measured for a diving sea snake was 50 meters, and the maximum time between breaths, 3.5 hours. Why do they do it? We still don't know, but presumably it must be important to them, since some spend up to 99% of their time down below. It's baffling. There are other vessels, apart from the research boat, working along this drift line. They are fishing for shrimp, and shrimp only. The rest of Pilamis's neighbours are thrown back, which seems a wasteful way of fishing. But it suits the dolphins very well. This fisherman treats the snake with great caution. When washed up on the shore with the other rejects, there is something about a Pilamis which puts off even land dwellers. A vulture is not normally at all fussy. But they don't like snakes, and this one, being black and yellow, seems to carry a particularly strident warning. Nothing, it seems, is too anxious to interfere with Pelamis. But ashore, Pelamis is practically helpless. It has become so specialized for the drifting oceanic life that it has completely lost its ability to move about on land. Such is the price of extreme specialization. Pelamis is now pushing against the limits of its range. It can't cross land, and it has expanded across the Pacific as far as is possible in terms of temperature. To the north and the south, it's hemmed in by cooler waters. So where can it go next? There's one chance. The Panama Canal. Here is a connection between the Pacific and the Atlantic Oceans. It's 44 miles long, a thin thread of water across the narrow isthmus linking the North and South American continents. Surely Pelamis could slip through here and then conquer the Atlantic too. But no, this is the obstacle, a strong current as the canal waters fall 70 feet from an inland lake. Pelamis could probably cope with the fresh water in the lake, but the flow and the lock gates are too much. Once again, its passive, specialized lifestyle has reduced its options. But there is still a chance, and trade and politics are the key. There's talk of another sea-level canal being built for economic and strategic reasons, and that might suit Pelamis very well. So stand by the Caribbean, Florida, and Atlantic. Pelamis could be on its way. It's even reckoned that it could survive in the English Channel in summer. Now, there's a thought for you when you go for a swim.
Tonight at 8:30, BBC One visits one of the most famous primate zoos in the world, Twycross in Warwickshire.